Welcome to our continuation on video lecture 5 for module 4. We were talking about examples of normal distribution. I've done the forward and backwards, or the dist and the inverse command for Excel for normal distribution standard. So I showed you guys the commands involved in calculating probabilities that you will be below a certain value, z value that is, or above, and how do you go backwards for that is what's coming up, meaning we will be starting now to look at the following question. Recall we're dealing with a standard normal distribution. Again, we did the forward problem above, meaning I was giving you z and you were giving me p using two different commands. The norm.s dist and 1 minus norm.s dist. So if I ask you for the area on the left, that's the natural one, that's the original Excel command, and if you want the area to the right, it's 1 minus. Now let's switch the question. Let's go to the inverse problem. And now let's say I have given you the probability and I'm asking you to give me the z-score. Again, we're dealing with a standard normal distribution inverse problem. We're going to be dealing with a non-standard normal distribution, and that will also have a forward and inverse problem too. That's why I originally said there are 4 different types. We've done one of them for standard. Now we're doing the second one for standard, and we'll have 2 of them left for non-standard. Okay, so the inverse problem here means the following. For example, I'm going to look at the following normal distribution. That's the z-axis, that's the p-axis. And guys, when you're doing these, it's not just about typing a command. It would be a good idea for you to really learn it. And again, you're going to need to know this stuff for your future courses, so you're not just trying to get a good score. So try to understand what's going on here, and when you're doing the exercises, try to draw the picture so you get a feel for what the question is, so you're just not memorizing just an Excel command. All right, so let's look at an example here. We have the z-axis, the p-axis. We're dealing with a standard normal distribution, and we are talking about the backwards or the inverse problem. And how is that going to come at you? Well, the question will say, okay, I'm interested to know what z value will give me the top, and let me change colors here, will give me the top, say, let's say about 8%. So this yellow area here is 8%, 0.08, since we're going to use decimals to write it. So the question is, and the question will come to you as to what's the z-value that will put you in the top 8% of the normal distribution. So you could see this question as find the z-value. And the moment you hear find the z-value, you should know that whoever is asking you the question is indirectly telling you that you're dealing with an N01, you're dealing with a standard normal distribution. So the commands you type on Excel must have .s in them. So that's what you get when you see find z. Okay, and when we talk about non-standard, it will say find x. So that's a big indicator for you to realize when the question says find z, it means they're talking about the standard normal distribution, which in Excel translates to typing .s to whatever command you're typing. Anyways, going to the question. So if I wanted you to give me the z-value that will put you in the top 8% of the standard normal distribution, the question will say find the z-value that exactly that will put you in the top 8%. And obviously that's what we're talking about, top. That's the top part of the normal distribution. This is the bottom part of the normal distribution. So when I say top, bottom, you know what I'm talking about. All right, so the question could be that. But the question could also say, I mean, and I've been telling you this even during class time when I was in class, I kept saying, you know, you could also use percentiles to ask such questions when you're talking about the probability below the area, below some certain numerical value. So, for example, and also we talked about the fact that mathematicians want to write things shorter. So I could say, I could ask this question that I asked you above using all those words. I could just simply say find P what, guys? 92. You guessed it right. That means I could just say find the 92nd percentile. That means the bottom 92%, which obviously means the top 8%. So I could ask you the same question in two different ways, and they both would be the same. It would both mean that I'm asking you to find, and here goes a yellow color, this value here, which is some z value. So both of these questions, question 1 and question 2, will asking you the same thing. So don't mix them up when you see them different in different places. They're asking you for the same thing. They're asking you for the point that separates the bottom 92% from the top 8%. And what would be the command for that? Well, the command for that on Excel will be equal to, what do you think we're going to type, guys? Well, we're going to type norm dot, it's a standard normal distribution, right? Right, dot S. But we're doing the inverse problem, so type dot inverse, open parentheses. And here you have to type a probability. And the probability you type, not 0.08, you're not going to type 0.08. Remember, Excel is only capable of doing calculations if you give it the probability to the left, the cumulative probability. Probability is always to the left of the value that you're trying to find. So Excel doesn't like the top probability. Excel always likes the bottom probability, the cumulative probability. So even though you're dealing with a 0.08 value that's been given to you, but when you want to type the command on Excel and get that z-score, you have to type the area that's below that value, not above. So that's why here you type 0.92 or 92%. And that will give you a z-score. And if you press enter, you'll get 1.40507156. Now, of course, during the test, if you're dealing with an x or a z value, I'll be asking you to round that to 2 decimal places. And that's very important for you guys to follow, because you're going to be taking this test on a spreadsheet, on Canvas, and you have to be careful because it's sensitive to number of decimal places. You may get it wrong even though you type the right answer, but not enough number of decimal places. So make sure you round this to 2 decimal places. And that's the answer. That means the z-score that will separates the bottom 92% from the top 8% is 1.41. All right, so we're going to continue. Now we talked about the inverse problem when the top area is given to you. Okay, well, let's talk about the inverse problem when the bottom area is given, which is the pretty much an easier version of it, but let's look at it. So say I have given you the following normal distribution. So looking at another example. So let's say I've given you the bottom of the normal distribution. It's a standard normal distribution, which means the center is 0. Let's say I am asking you to give me the z-score that will put me, let's say, in the bottom 5% of the normal distribution. So if I color this white, and this area here is 5%. But since we're going to use decimals, we'll just say 0.05. So that area is 0.05, and I'm asking you guys to find that z value. And of course, don't forget, this is the standard normal distribution, so that's the z-axis, and that's the p-axis. And the origin is 0 for us here. All right, so basically I want you to find that z value, and since it's on the left side, you know it's going to be some kind of a negative number. Okay, so now, okay, so again, I could ask you to give me the z-score that will give you the bottom 5%, or I could have asked you the same question and say what is P what? 5. That's correct. So all I'd have to say is find P5. And that would mean exactly this example. Basically, I'm asking you to give me the z-score that separates the bottom 5% from the top 95%. Now, what would be the command? It will be equals to norm, because it's a normal distribution, dot, it's a standard, so dot s, dot, we're doing an inverse problem, open parentheses, and type the area below that number you're trying to find. But in this case, you don't even have to subtract anything, because in this case, it has given you the area below the number you're trying to find, so you just type 0.05. You see in the example above, I had given you the top area. So if you wanted to type the Excel command here, you would have to use the area to the bottom of the value I had given you, because Excel always wants the area to its bottom side, not to the top side. But in this one, I've already given you the area to the bottom or to the left, or on the left side of the distribution. So therefore, naturally you have what Excel needs. You don't need to change it like you did for the one above. So every time you have the area to the left, that's good, you just type it. But every time you have the area to the right, you always have to subtract it from 1 in order to type it in Excel. All right, so, and if you do that, Excel will give you this value, negative 1.644853627. But of course, again, if you're writing this on a Canvas test or something, and I'm asking for 2 decimal places, then obviously your answer will just be negative 1.64. Very good. So let's continue with, now I've given you 2 cases for the forward standard normal distribution. Okay, so we talked about giving you z and asking you for p, and we also talked about giving you the p and asking you for z. So we've done both problems here. So let's just go through some general examples so that we can get used to doing these types of calculations. Okay, let's continue with our examples. Now, let's start with the following, guys. Let's see. Find the probability that z is between, say, minus 1.32 and 1.78. Again, in order to do this, you just have to remember the command for it, but as I said, to comprehend it and intuitively be comfortable with it. Whenever you come across a question like that, at least initially that you're learning this, always draw the picture to see what they're talking about. Well, what are they talking about here? They're saying we have a standard normal distribution. Why? Because I've given you a z. So I have a standard normal distribution. That's my z-axis. This is my probability axis. That's 0. So basically the question says find a probability that, well, that means find the area under this curve between negative 1.32, which is obviously on the left side, negative 1.32 to 1.78. So basically we're talking about, give me that area. How much is that? Or what is that probability? Same thing. So how would we find this on Excel? And how would you calculate it out? That's right, you have to find the area of a ribbon. So we do, so it's not a single one, so it's a subtraction of 2 of them, so it'll be equals. We're dealing with a normal distribution, standard. We're doing with the forward problem, so it's the dist problem. Open parentheses, now it's asking you for a z-score. We'll start with the top one, 1.78. That's right, comma, cumulative, which you write true. Okay, well that will give you the area all the way from 1.78 to all the way to the negative side. And then, but you want to cut it at negative 1.32, so you have to, from that, subtract the norm dot s dot dist of negative 1.32 comma true. And that will give you the in-between area, which you round it to 4 decimal places, is 0.8690. So that's the answer to the original question. What's the probability that z is between those two numbers? The probability of the strip be 0.8690, which is about 87%. And for probabilities in this chapter, in this module, you'll have to use 4 decimal places. So for x's and z's, you have to use 2 decimal places. For p's, you have to use 4 decimal places. Now, I'd like to type that for you on a spreadsheet for you guys to actually see the Excel command. I mean, I'm writing it, but let's see if I could generate that 0.8690 value here. Let me go to my spreadsheet. So norm.s.dist. So it's asking me for the z. The z value is the top on 1.78. And then this is true. Okay, get out. So that's it's a little different if you're doing this on a PC. You just double click on true, and true will come without the red parentheses, but on an iPad it comes with the red parentheses. It's the same thing, so it's, I guess, a little different on an iPad Excel than a PC version. Anyhow, so minus, so that'll give you the area to the left of 1.78, minus, then you take out the area to the left of negative 1.32, and that'll give you the in-between area, obviously. So it's norm.s.dist again. This time the z-score will be negative 1.32. And cumulative is true, and you click on that, and that's the command. And hopefully when I press enter, I'll get 0.8690. I mean, at least the 4 decimal places. That's right, that's 0.8690. So one more time to show you the command. That's the command, and if you execute that command, you get 0.8690. Great. So let's go back to our examples. So let's say I ask you, let's say my next question is example. Okay, so let's say I'm asking you to find a probability that z is between negative 2.32 and minus 1.58. All right, well, I'm still asking you to find a probability of a strip, so it'll just be the norm s dist of the top number minus norm s dist of the bottom number. But just to visually see it, let's just draw it again. It'd be a good thing to do it for the first several examples so you could get comfortable with the visual aspect of it, or at least in the back of your head you know what's going on. Even if you're not drawing, you're just writing a command. So z-axis, p-axis, 0. But this time both values are negative, so obviously I'm dealing with a strip that's completely on the negative side. So that's the strip. It's between negative 2.32 and negative 1.58. So basically I'm asking you guys to find that white probability there. So that's the question. How much is that probability? How much is that area? And this is exactly like the one before. It's just that the strip has moved to the bottom of the distribution. It really doesn't matter where the strip is, as long as it's asking you to find the area of a strip. It will always be the norm s dist to the top number minus the norm s dist to the bottom number. So again, the command here will be equals norm.s.dist of negative 1.58 comma true minus the norm.s.dist of negative 2.32 comma true. And if you execute that, you round it to 4 decimal places, it'll be 0.0469. So it's a small area, it's about 5%, and that's the answer for that. Let's move on and try to find this here. Let's say another example, say asking you to find the probability that z is greater than 2.13. Well, you see, the reason I'm telling you to always draw it, because at this point, just trying to figure out what command you should use to do it would not be a good idea, because chances are you'll get the wrong command. Because the questions in Excel aren't always in a standard kind of a form for you to just type it up on Excel. You may need to do some 1 minus or whatever. So it's always a good idea when you see a question, before you jump to trying to figure out what command to use, would be to actually try to draw and to see the picture, to see what they're asking you to find. So let's draw the distribution here. Let me draw my z-axis, draw my p-axis. All right, so here it's telling you that I want you to find a probability that would put me above a 2.13 z-value. Well, if that's 0, 2.13 will be here somewhere. And it's telling me to find a probability. I'm going to use a yellow color for that, so it's asking me to find that probability. That's a probability that's above 2.13. So it's asking me to find that yellow probability. Now, if I say, if you, okay, now this is a standard normal distribution, and this is a forward problem, the dist problem, because I've given you a z-value and asking you to find a probability. If you just typed norm.s.dist, open parentheses, you type the z-value, which is 2.13, comma, true. If you type that into Excel, what do you think you're going to get? You're going to get some value that's more than 50%. Yeah, that's not, because this probability here has to be, because remember, the property says that like an entire half of a normal distribution is 50%, which is 0.5. So how could a little yellow area that's obviously less than 50% be greater than 50%? So you see, the thing is that if you just blindly type the norm.s.dist of 2.13 true, the answer the Excel is going to give you, remember, what does Excel like to naturally get or give? It always wants to give the bottom area, or get the bottom area to do the calculations for you. So if you just type norm s.dist of 2.13 true, Excel is going to come back and tell you, well, that's the area that I given you. So it gives you the area to the left of 2.13 because that's a natural area Excel wants to give out. So, but that's not what you want. You want the top area. So here, see, if you didn't have that picture, you wouldn't have recognized that. So therefore, what you do is, instead of typing norm.s.dist of 2.13 comma true, you type 1 minus that. 1 minus the norm.s.dist of 2.13 comma true. Because this will give you the bottom area, and then you take the bottom area, you subtract it from 100%, and it'll give you the top area that you're looking for. So if I was asking you to find the probability that z is less than 2.13, then this command would have sufficed. But if I'm asking you to find a probability that z is greater than 2.13, you have to do 1 minus. So remember, if I'm asking you to find a probability that z is less, no matter what, you just go with this command and you don't need to type 1 minus. But if I'm asking you to find a probability that z is greater than, then you always have to do 1 minus. You always have to do 1 minus. So you always have to do 1 minus if it's greater than question. If it's less than, then you just go with the original norm.s.dist command. And if you type that, the answer should be, and I'm going to write the answer here, 4 decimal places, and it should be a small answer, 0.0166. That's about 2%, and that's correct. Great, let's look at another one here. Let's see if I could cook another one. Let's see. Let's say I'm asking you to find the probability. Another example, probability that z is less than negative 2.34. All right, let's talk about finding the probability that z is less than negative 2.34. Now here, you could look at this and you could say, okay, well, I'm trying to find the z less than, so this is the natural case for Excel, so I don't need to worry about 1 minus. So I could just say the answer will be equals, sorry, change that to y to make it thinner. All right, so I could just say my command will be equal to norm.s.dist negative 2.34 comma true or cumulative. And of course you'd be right. And if you type that, you'll get rounded to 4 decimal places, that is, you get 0.0096. That's like almost 1%. So 0.96%. So it's a small probability. But again, it's always a good idea to just get a feel for what it looks like, especially if you're just beginning to learn these techniques. So that's the z-axis. This is the probability axis. Let me draw the normal distribution. All right, so the center is 0. So find a probability that z is less than negative 2.34. Negative 2.34 will be there. And if I go to yellow, basically it's asking you to find that yellow probability, or basically yellow area. So what is that probability for that z-score? So basically the probability left the negative 2.34. And since that's a natural default probability for Excel, then you don't need to do 1 minus. You could just type norm.sdist of negative 2.34 comma true. Great. Let's move on and look at another example. Let's see. They're all quite simple. So we could say, let's say example, find the probability that z is, say, less than 1.27. Now, again, this is the less than case, so that's a natural default probability for z. So that will just be equal to norm.s.dist 1.27 comma true. And if you type that, you should get to 4 decimal places, that is 0.8980. So about 90%. It's pretty high. And again, just to get a feel for what it looks like, I'm going to just try to draw it. That's the z-axis. That's my p-axis. Here's my normal distribution. 0, so 1.27 is a positive value, so it should be to the right of that, 1.27. And I'm asking you to find a probability that z is less than that. So I'm asking you to find this yellow probability here, yellow area there. And since that's a default area for Excel, you don't need to type 1 minus. Now, if I would have said, find a probability that z is greater than 1.27, then that would have meant that I'm asking you to find that probability. And that's not the natural probability for Excel. So for that one, you'd say 1 minus norm.s.dist of 1.27 comma true. So it would be the exact complement of that. It would be 1 minus 0.8980. So that would be the connection there. Very good. So these are all forward standard examples. Now let's do some inverse standard examples. Exactly, which means here I'm going to give you the probabilities and I'm going to ask you to find the z-scores. And the base command is, so again, I'm giving you the probability. So probability is given now. And I'm asking you to find z. So this is the inverse problem. So my commands are all norm.s. Not dist anymore, but inverse. And here is nice because all you have to type is how much is the probability, the natural probability for Excel, which is probability to the what? You guessed it right, to the left. I call that Excel's natural probability. So it's always probability to the left. So that's the general command. All right, so let's look at our first example. So let's say I have the following distribution. Again, I can ask you this question 3 different ways. I can give you a picture, which I am. That's the most intuitive one. That's the z-axis, that's the p-axis, that's 0. And let's say I told you that I have the bottom 5% of the normal distribution given. So this yellow area here is 5%. So that yellow area there is 5%, which is 0.05, because remember we deal with decimals in this class. And I want you to basically give me the z-score that will give you that 5% separation from the top. So I can ask you that. I could just say, just give you this picture, this diagram, and you'd know exactly what I'm asking you. Or I could use the percentile language and say, find P what? Right, P5. That means the 5th percentile, the bottom 5%. Or I could basically say, give me the z-score that separates the bottom 5% from the top 95%. Or I could just say, give me the z-score that separates the bottom 5% of the normal distribution. So all of that means the same thing. Now, how do you find it? Well, we type equals to, we're dealing with a normal distribution. It's a standard normal distribution, and it's an inverse problem. And all you have to do here is to put in the natural probability for XL for that particular z value. And natural probability for XL is the bottom area, which in this case is literally given to you. It's 0.05. So you just type 0.05. Oh yeah, oh my God, yeah, it's that easy. And then you press enter and I'll give you the z value. So the z value will be negative 1.6448533627. And here I can ask you to round it to 2 or 3 decimal places. So let's say if I round it to 2 decimal places, I get negative 1.64.